Welcome to I'm Not Afraid of Math Anymore, Math Foldables. In this lesson, we will look at algebra expressions again, and this time we will learn about multiplying binomials and factoring trinomials. On the outside of our foldable, we will be multiplying binomials with a process called FOIL. And on the inside of the foldable, we will be undoing that process when we factor the trinomials. Remember that a binomial has two terms, like a bicycle has two wheels. So we are going to be multiplying two binomials. Each of those has two terms. Our first binomial is x plus 3, and our second binomial is x plus 5. We can do this fairly simply with a process called FOIL. F stands for first times first. So we're multiplying the x in the first binomial times the x in the second binomial, and our answer for that is x squared. We put that under the F. Next, we are going to multiply the outsides together. X times 5. Both of those are on the outsides, the extreme outsides of our whole problem. X times 5 is 5x. It's customary to put the number in front of the letter, so that goes under the O. Next is the insides. The I in FOIL stands for insides, and so x and 5 are on the outside, and 3 and this x are on the inside. 3 times x is 3x. That goes under the I. And then last, we will be multiplying the last term in the first binomial, which is 3, times the last term in the second binomial, which is 5. And the L does stand for last. 3 times 5 is 15. Now we have two terms in the middle that are alike. They both end in an x, so we can add our 5x and 3x together to get 8x. And we just bring down the x squared from the F and the 15 from the L. So the final answer for multiplying these binomials is x squared plus 8x plus 15. And this is now a trinomial because there are 3 terms. The next pair of binomials is very similar, except this time we have x minus 3 in the first binomial. We will use the FOIL process again. So first times first is x squared, and that goes under the F. And then x times 5 are the outsides again, and that goes under the O, 5x. And then we have negative 3 times x for the inside. Notice that I'm taking the negative sign with the 3. So the answer for the inside is negative 3x. And then last, it's negative 3 times 5. And that is negative 15. We are always going to be taking the sign that is right in front of the number. So that was negative 3 times 5 for a negative 15. Now that we're through multiplying with the FOIL, we can combine the two terms in the middle that are alike. 5x minus 3x is 2x. We bring down the x squared and the negative 15 again. And our final answer is a trinomial, that is x squared plus 2x minus 15. In this problem, it's our second binomial that has a minus sign this time. We follow the same process. First times first is x squared. It goes under the f. Then we have x times negative 5 for our outsides. Remember that we take the sign with the number. So that is negative 5x. Our inside is 3 times x. So that is 3x. And last is 3 times negative 5, which is negative 15. We're through multiplying with the FOIL, so now we combine the two terms in the middle. We're going to need to take the negative sign with the 5 and combine negative 5 plus 3. Negative 5 plus 3 would be negative 2. Our final answer is x squared minus 2x minus 15. In this problem, both of our binomials have a minus sign, so we have to think very carefully about our rules for multiplying and dividing and adding and subtracting positive and negative numbers. We follow the same process. First times first is x squared. Then we have the outsides of the whole problem, which is x times negative 5, and that is negative 5x. Then we do the insides, which is negative 3 times x for negative 3x under the I. And last is negative 3 times negative 5, taking both of those minus signs. And then remembering that when the signs are the same and we are multiplying, that our answer is positive. So the number under L is positive 15. We now need to combine the second and third terms, those two terms in the middle, the O and the I, and we have negative 5x minus 3. So if you're imagining a number line, we would start at negative 5. There's one minus sign, so we would move left 3 spaces down the number line, and that would give us negative 8. Our final answer this time is x squared minus 8x plus 15. Now we're going to move on to undoing FOIL, which is factoring the trinomial answer that we got when we used FOIL to multiply binomials earlier in this video. Factoring means to break it back down into the things that were multiplied together to get an answer. That answer was x squared plus 8x plus 15. So what two binomials would need to be multiplied together to get x squared plus 8x plus 15? We will start by setting up two sets of parentheses for our binomials with an x at the beginning of each one. Then we'll start looking for two numbers that multiply to 15 and at the same time add to 8. It's easy to start with 1. 1 times 15 is 15. But when we add 1 plus 15, we get 16 and not 8. So this is not what we were looking for. Next, we can move up to 3 because 2 won't work. We can't say 2 times a whole number and get 15. But we can say 3 times 5 is 15. And then when we test that by adding 3 plus 5, we do get 8. That is a match. So now we have the two numbers that we need to finish our binomials. X plus 3 times x plus 5 would give us x squared plus 8x plus 15 if we did that whole FOIL process again. In a later lesson in the math books that go along with these foldables, you would learn the process of actually solving the mystery of how much the x is when we make the whole thing equal to 0. And that is going to be the opposite of what we've put over here with the x's in our binomials. So the opposite of positive 3 is negative 3, and the opposite of positive 5 is negative 5. We will undo FOIL with x squared plus 2x minus 15. We set up our two sets of parentheses for our two binomials, putting an x in each one. Then we start looking for two numbers that multiply to negative 15 and at the same time add to positive 2. 1 times negative 15 is equal to negative 15, but 1 plus negative 15 is equal to negative 14. We're looking for positive 2, so that is not what we need. We can move to 3. 3 times negative 5 is negative 15, but 3 plus negative 5 is negative 2. It's the right number, but it's the wrong sign. So we're closer, but we're not quite there yet. We can flip the signs on the 3 and the 5 and multiply negative 3 times positive 5. We'll still get negative 15, and this time when we add negative 3 plus positive 5, we'll get positive 2, which is the match that we are looking for. It's the right number and the right sign. We have found the two numbers that we need to finish our factoring and to put into our binomials. Notice that x minus 3 times x plus 5 is the same as what we had started out with earlier. And to finish solving it, when we make it equal to 0, they're in the right corner. We change the negative 3 to positive 3, and we change the positive 5 to negative 5. Notice on the left that we have two binomials that are multiplied together, x plus 3 times x minus 5. We did this problem earlier in this video. We multiplied using FOIL. We combined the like terms, and we ended up with x squared minus 2x minus 15. Now we're going to start with that trinomial answer, and we're going to factor it. We're going to undo that trinomial and break it back down into the two binomials that we started with. We start by setting up our binomials with two sets of parentheses and putting x in the beginning of each one. Then we are going to start looking for two numbers that multiply to negative 15 and that at the same time add to negative 2. 1 times negative 15 is negative 15. When we add it, we get negative 14. That's not what we're looking for. We're looking for negative 2. So that's not what we need. So we're going to move to 3 times negative 5 to be equal to the negative 15. And then when we test those numbers, when we add them, 3 plus negative 5 is equal to negative 2. That is a match. That's exactly what we were looking for. So we have now found the two numbers that we need to put back into our binomials over here. Putting those numbers in, we have x plus 3 times x minus 5. Again, that is the same as what we started with over here. And looking in the right corner, we take the positive 3 and turn it into negative 3. And we take the negative 5 and turn it into 5 to actually solve this equation that has now been made equal to 0. For our final example, look at the left and notice that we have x minus 3 times x minus 5. That's a binomial times a binomial. We used FOIL and we combined the two like terms in the middle, and we ended up with x squared minus 8x plus 15. We did this problem earlier in the video. Now we are going to take this trinomial answer and we're going to undo FOIL so that we can factor this trinomial back into the original two binomials that were multiplied together. We start by setting up the problem with two sets of parentheses with an x at the beginning of each one. Then we start working on looking for two numbers that add to positive 15, that at the same time also add to negative 8. We start with 1 times 15 and get positive 15. But when we add 1 plus 15, we get 16. 16 isn't what we're looking for. We're looking for that negative 8. So we move to 3 times 5. 3 times 5 is 15. If we add 3 plus 5, we get positive 8. So it's the right number, but it's the wrong sign. So we're not there yet, although we are close. We can fix that by changing the signs on the 3 and the 5 so that each of them is negative. Negative 3 times negative 5 is still positive 15 because the signs are the same, so the answer is positive. When we add negative 3 plus negative 5, we end up at negative 8. That is the right number and the right sign. It is a match. So we have found the two numbers that we need to put into our binomials to complete our factoring. So now we have x minus 3 times x minus 5. And notice that this is the same two binomials that we started out with. So we have done FOIL and we have undone FOIL. If you look then in the right corner, you will see that we use the opposite of the numbers that we put in our binomial. We changed our negative 3 to positive 3, and we changed our negative 5 to positive 5. When the equation was made to be equal to 0, our x would be equal to 3 or our x would be equal to 5. We will learn more about that in a later lesson in the math books that go along with these foldables.